said I'd only take a short break after lunch before resuming work. But before I knew it, look at the time. Anyway, I'm back to doing more of this. So, I was gonna follow the tutorial, but I just remembered Mark Brown actually made this. I never added it to my watch later, apparently.
Hi, my name's Mark. For years, I've wanted to make my very own video games using software like Unity. Unity is the powerful game engine behind titles like Cuphead, Neon White, Tunic, Outer Wilds, Hearthstone, Firewatch, and even the Pokemon Diamond remake. But I've always found that lengthy, multi-part, meandering tutorials just send me to sleep. I can't learn by watching someone else. I have to get hands-on and figure things out for myself. And so last year, I developed a solution that actually works. It's a 3-step technique where you, 1, just learn the absolute basics of Unity, then 2, cement those lessons with simple exercises, and then 3, figure out the rest as you go along. And it totally worked. In the space of about a year, I went from ripping off iPhone games to working on my very own puzzle platformer about magnets. And I released an interactive video essay that's had over 100,000 plays. But wait, I hear you say, how do you do step 1? How do you learn the basics when the software is so complicated to figure out? Well, for me, it was about writing down a list of things I would need to know regardless of what game I was going to make. Things like how to make a character appear and move them around the screen, how to make stuff spawn in and then delete it again later, how to have collisions and game over and animations and sound effects. Then I learnt all that by hunting through lengthy tutorials, reading the Unity docs, googling esoteric words, and doing a lot of trial and error. And so the whole point of this video is to save you that hassle. This video is the tutorial
What the fuck?
I wish I had when I was learning Unity. So in the next 40 minutes, we're going to use the engine to make Flappy Bird. Not because we want to make Flappy Bird, but because in order to remake this addictive iPhone game, we'll need to learn basically everything I just listed, from spawning objects to getting game overs. This tutorial will cover every step of the way, from downloading Unity to understanding the UI, to writing your very first line of programming code, to building a game that you can share with your friends. And then, when the tutorial is over, I'll share some concrete next steps that you can take in order to continue learning the rest by yourself. Sound good? Then let's get started. Okay, let's start by getting Unity from the website.
My plan.
Download and install the Unity Hub, and then you'll need to make a free account to actually use it. Once that's done, you'll be asked to install the Unity editor. I'm using version 2021.3 for this tutorial, if you're watching a million years in the future and wondering why things are different. Let's pretend I have fast internet. We're not quite done yet. Under Installs, hit the cog icon on the Unity editor and pick Modules. You'll see that Microsoft Visual Studio has been ticked. This is the software we'll use to write programming code. So hit Continue and install Visual Studio. On this screen, scroll down and tick Game Development with Unity and untick Unity Hub because we already have it. We don't need to make an account to use Visual Studio, so skip that and don't bother loading it, we'll open it later. Okay, that's all done now. So in Unity Hub, pick New Project, choose All Templates, and use 2D Core. This is an empty project with a few configurations to make it suitable for 2D games. Give your project a name, hit Create, and let's get game making. In step 1, we're going to become familiar with the default Unity user interface, and as we explore the different panels, we'll make the bird appear on screen. Right, so this is the default screen layout for Unity, and it's split into 4 panels. First of all,
Oh my.
down here is the project panel. This will contain everything that is in our game, like sprites, sound effects, scripts, tiles, fonts, and so on. Some of this stuff will be made in Unity as we go along, but we can also just drag and drop files from elsewhere on our computer. Like, I've made some sprites for the bird and the pipe in Photoshop, and I'm going to import them into my project like so. I'd recommend you make your own, that's always more fun, but if you have zero artistic ability, then check the description for these assets. The next panel is the hierarchy. This contains all of the stuff that's in the current scene, which in most games will be a level. We're going to start by making the bird, so right-click and choose Create Empty. This has made an empty game object. So, what's that? Well, a game object is essentially an invisible container. It has a position in space, a rotation, and a scale. Then you can fill that container with components to add extra features. For example, if we add a sprite renderer component, we can slap the bird image onto the game object. Absolutely everything in our level will be a game object with components. The bird, the pipes, even the user interface, and the camera.
Why does Unity take so long? I thought by now, since I've loaded this project so many times now, there's barely anything in it.
All of this magic happens in the third panel, even the user interface and the camera. Everything in our level will be a game object with components. The bird, the pipes, even the user interface and the camera. All of this magic happens in the third panel, the inspector, which is for messing with game objects. So once we've selected our new empty game object, we can put a name in the top field, let's call it bird, and we can see and change the game object's position, rotation, and scale under transform. We can now press add component, pick rendering, and pick sprite renderer. To make this work, we need to fill in the sprite field, so just drag the bird image from the project panel into the field, and voila, we have graphics. That will, of course, show up in the
Alright, epic. I'm just gonna go ahead and delete this. I decided I want to listen to music. The karaoke people are so annoying. There's a specific song by M2U I want to listen to. I forgot the title of it though. There it is. Ah, that's actually a really good. I'll keep this. I am close enough to see your eyes. But tell me who I should be like. No stop printing black up in the white twice. Stop printing me, stop rewind. I am close enough to hold your hands. So can't something taste to be a man. So many choices, too many voices, and I know they only steal me away from you. Not 151 songs on this on this mix list is fine. For these. It's big.
The fourth and final panel, the scene view. Here we can see what's in our current scene, and we can slap the bird image onto the game object. Absolutely everything in our level will be a game object with components. The bird, the pipes, even the user interface and the camera. All of this magic happens in the third panel, the inspector, which is for messing with game objects. So once we've selected our new empty game object, we can put a name in the top field, let's call it bird, and we can see and change the game object's position, rotation, and scale under transform. We can now press Add Component, pick Rendering, and pick Sprite Renderer. To make this work, we need to fill in the sprite field, so just drag the bird image from the project.
Oh, you can do that from the inspector.
To make this work, we can now press Change the game object's position. We can put a which is for messing with. All of this magic happens in the third panel, the inspector, which is for messing with game objects. So once we've selected our new empty game object, we can put a name in the top field, let's call it bird.
Ah, I see he made an empty object specifically. Sure, I'll follow along. To the animation?
And we can see and change the game object's position, rotation, and scale under transform. We can now press Add Component, pick Rendering, and pick Sprite Renderer. To make this work, we need to fill in the sprite field, so just drag the bird image from the project panel into the field.
Nanny. What? Okay. Huh. But why? Hey, wait a minute. There's already a sprite renderer here. What exactly is this then? Okay. Pretend that never happened.
And voila, we have graphics. That will, of course, show up in the fourth and final panel, the scene view. Here we can see what's in our current scene, and if you want, you can use these tools to move stuff around, scale it, and so on. This section has an extra tab for Game View, which shows us what the game will look like from the main camera when it's running. Also, from this drop-down, we can set a resolution or aspect ratio to get a better idea of what it will look like when played. So I'm going to choose 1920 by 1080. Oof, the bird takes up way too much space. We could scale it down, but let's actually just zoom out the camera. Like I said before, the camera itself is a game object in the hierarchy, and it has a camera component with stats we can mess with. By changing the size, we can zoom out. I'm also going to change the background color. Lovely. We can now press the play button up here to start the world's most boring game. Okay, let's make it a bit more exciting. A quick recap. Unity
Why the bird invisible? Do I somehow have this thing invisible or something? Okay. I'm gonna make that a problem when it becomes one. What's I gonna do next?
It has 4 panels by default. Project holds all the stuff in our
Oh,
game.
right, I was gonna
Hierarchy
say.
lists all the game objects in the current level. Inspector lets us see and change those game objects, and we can see the level in the scene view. And a game object is an invisible container that we can fill with components like a sprite renderer. In step 2, we're going to use more components to make the bird into a physics object that is affected by gravity. And then we're going to write some programming code to make the bird fly up when we press the spacebar. So let's add another component to our bird, a rigid body 2D. This turns our bird into a physics object with gravity. So when we hit play, the bird...
Cool. What's the point? I can't see it. Well, at least I can see that it is indeed falling down. Oh, that didn't work. Why the fuck are you invisible? I can't erase you, so you're important. How about I start a new project? Hmm. I appear to have made a mistake. What? But why is that happening? There we go. Oh, it's done. There it is. Why is the Z being... This is 2D game, sir. I'm afraid it makes no sense for you to be changing Z values like that. Alright, starting a new project, fixed it. For some reason. Hooray!
Drops and falls off the screen. Cool. We'll also want this bird to be able to interact with other objects, so let's add a collider, a circle collider 2D. Back in scene view, we can see the collider as a green outline. It's a bit...
Ah, whoops. Circle Collider 2D. What? Okay, there we go.
Bit off center for me, so I'll use the offset to move it. And a little game design trick. If we make the collider a bit smaller than the image, it will let the player get through the pipes even if they just touched the edge. It gives the game a bit of leniency.
I can't seem to manually edit this. I mean, I can only seem to manually edit this.
Get through the pipes, even if they just touch smaller than the image, it will let the player get through the pipe. If we make the collider a bit to move it. And a little game design trick. If we make the collider a bit smaller than the image, it will let the player get through the pipes even if they just touched the edge. It gives the game a bit of leniency and makes it feel more fair. The final thing to add right now, a script. This essentially lets us make our own custom component, but we'll have to write it ourselves using programming code. Choose New Script from the components list and call it Bird Script. Once it's loaded, double-click the script field.
Is my computer just low? Am I the problem here and not Unity?
To open it up. This will open the file in Visual Studio, which we installed earlier. So, welcome to programming. It's not too scary, promise, we'll take it slow. We're writing in C#, that's the programming language, and the only thing to worry about right now is these two chunks here, start and update. Start is for any code that will run as soon as the script is enabled, and it runs precisely once. Update runs constantly while the script is enabled, and it will fire off every line of code, every single frame.
Studio? None.
Over and over and over again. So the main thing we're going to be doing with code right now is, well, if we go back to Unity, see these numbers and text fields in the components and how we can change them in the Unity editor? We're just going to write code to change these stats while the game is running. Just as a dumb example, and we'll delete this in a second. In start, we can type GameObject, that refers to this bit up here, and then a dot. You'll see a list appear, and many of the items refer to stuff back in the inspector, like isStatic, tag, layer, and name. So let's pick name, then write an equal sign, and in quotes, give our bird a name. Finally, we must always use a semicolon to mark the end of a command. And we must always save the script with colon to mark in quotes, give our bird a name. Then write an tag, layer, and name. So let's pick name. Then write an equal sign and name. So let's pick name. Then
Oh well.
write an equal sign. And in quotes, give our bird a name. Finally, we must always use a semicolon to mark the end of a command. And we must always save the script before we go back to Unity. Now, when we run the game, the name of the game object has been changed. Nice. Okay, delete that code, that was just for sillies, but it shows us how we can use code to talk to the game. We can write a command by choosing someone to talk to, in this case, the game object, and then a topic of conversation, its name, and then a command. Change it to Bob Buddington. We'll be doing this a lot. So what we actually want to do is, in the Rigid Body 2D's component, under Info, we'll see a grayed out field for velocity, and we want to write some code to add upward velocity to the bird to make it fly into the air. The problem is, initially, a script can only talk to the game object's top bit and the transform. Right now, this script is completely unaware of the other components, so we need to sort that out first. We need to make a special slot on this script for a Rigid Body 2D, so we can then talk to it and send it commands. This is called a reference. We're going to create the reference up here, between the class name and the start function. We're going to write public Rigid Body 2D my Rigid Body. So we now have a slot to store a Rigid Body 2D, and we have a name that we can refer to make sure we're talking about this specific Rigid Body 2D. And because we made it public, it means we can access this slot from outside the script. So if we save and go back to Unity, access this slot from outside.
I'm back.
the script. So if we save and go back to Unity, we'll see that the script component now has a field for a rigid body 2D. We can drag the component into that slot and voila, we have established a
Baby, no nightfall.
and go back to Unity, we'll see that the script component now has a field for a rigid body 2D. We can drag the component into that slot and voila, we have established a line of communication
I bet.
between the script and the rigid body. Okay, back in Visual Studio. In Update, we can type my rigid body, then dot. And now look at all the things we can talk about. Angular drag, gravity scale, mass, these are all properties on the component. The one we want is velocity. We want to set this to a new number, and so just like before with the name, we'll write an equals. Now what we're actually writing here is a vector, which is two numbers to represent a position in 2D space, and in this case it's used to represent a direction for the bird to travel. We want the bird to go straight up, so 0, 1 would be a good one. I'm going to use vector2.up, which is a built-in shorthand for 0, 1. And to give it a bit more power, I'm going to multiply that vector by a number, say 10, which should send the bird flying up in the sky. Now, like I said before, any code in Update will run over and over again every frame. So if we save the script and hit play in Unity, off goes our bird. Bye! That's not what we want. We want this to only happen when the player hits the spacebar. So it's time to use the most fundamental bit of programming code, the if statement. An if statement is like a gate. You can surround some code with a fence, and every frame that code will be completely ignored, unless the game meets some specific conditions that are written on the gate, in which case the gate is open and the code is read and executed. So we want to say, if the player hits the spacebar, then add upward velocity. To do this, we can write if, and then in brackets we can write the condition. This time we're not talking to a component, we're talking to Unity itself, specifically its input system. So we'll write input dot. Then we can pick get key down, and in brackets, key
Oh, I love this song.
Code dot space. This asks Unity if the spacebar has been pressed on this frame, and then we'll finish with equals equals true. A quick note on equal signs. We use 1 to make the thing on the left be the same as the thing on the right, and we use 2 if we're just checking if the thing on the left is the same as the thing on the right. Cool? Anyway, so this code says if the spacebar has just been pressed, then, and then we'll use curly brackets, these are the fence in our analogy, and put the flap code in here. So now in update, every frame the game will go to the gate and be asked, hey, has the spacebar just been pressed? If yes, the code will fire and the bird will flap. If not, it will skip the code in the curly brackets and try again next frame. So, save the script and go back to Unity. We can now hit play and, ta-da, the bird goes up when we press space. We have now created a character and made it react to input. This is a video game. Hooray! However, it feels like trash.
Ah, that's the beauty of any key, huh? I can press 2 simultaneous buttons and it will only register as 1. If I try to press too many at once, it has a hard time registering it. Which could be a problem, especially if you're making a game like AutoPie. Oh well.
The flap isn't right and it doesn't feel like the original iPhone game. So we could change this number, save, open Unity, run the game, not quite right, stop, change the number, save, but that's slow and dumb. Let's do something smarter. First, we're going to make a variable. Let's go back to the top of the script and under our reference to the rigid body, let's make a public float called flap strength. A float is a floating point number, basically a number that can have a decimal place. And then back in our update code, we'll multiply the vector2.up by flap strength instead of 10. Now, back in Unity, you'll see that the script component has a new field, flap strength, and we can change that whenever we want to make the game feel different. We could even change it during the game, but note that anything you change while the game is running won't save when you press stop. This means you can play with values to your heart's content.
Cool. It adds a space on its own. Oh my goodness. What a monstrosity.
Without worrying about screwing up your game. So, if we mess with the flap strength and also the gravity scale on the rigid body, we'll hopefully get to something that feels good. Changing numbers back and forth. Honey, that's game design. Recap time. We can use code to change the properties of a component while the game is running. A script cannot talk to the other components on the game object by default. You have to make a line of communication by storing a reference to that specific component. We create the reference in code and then fill it in Unity by dragging and dropping.
How about save?
Code in start runs once when the script comes into existence. Code in update runs continuously every single frame. But we can use if statements to skip some code unless a condition is met. And we can use public variables to change certain values in Unity's inspector even while the game is running. Okay, so the secret to Flappy Bird is that while it looks like a bird is flapping along through a world of pipes, it's actually not. The bird stays completely still, and it's the pipes that move across the screen. So in step 3, we're going to make pipes spawn into the world, move across the screen, and then delete themselves. We'll start by making the object we want to spawn. This will be 2 pipes which move across the screen from left to right. Let's make another game object called pipe. Put it exactly on the bird for now to get the sizing right. And then we'll make another object within this one called top pipe. This is a child of the first game object's parent. This way we can nest multiple game objects and move all of them at once just by moving the parent. So let's repeat what we did for the bird. Add a sprite renderer for the pipe image. And add a collider, a box collider 2D this time. We don't need a rigid body because it's not going to be affected by physics. We can then move it up above the bird, but keep the X position as 0. Finally, we can duplicate this whole top pipe object, call it bottom pipe, and flip it upside down by changing the Y scale to -1. Then move it down below the bird. As you can see, if we mess with the pipe parent game object, both pipes move, scale, and rotate along with it, with the parent as the pivot point.
Oh, you can't put spaces on the name. I'm so stupid.
all of them at once just by moving the parent. So let's repeat what we did for the bird. Add a sprite renderer for the pipe image. And add a collider, a box collider 2D this time. We don't need a rigid body because it's not going to be affected by physics. We can then move it up above the bird, but keep the
Oh, what the fuck?
position as 0. Finally, we can duplicate this whole top pipe object, call it bottom pipe, and flip it upside down by changing the Y scale.
My god, that is a terrible naming convention. Oh well, he'll learn soon enough. He probably already has.
To -1, then move it down below the bird. As you can see, if we mess with the pipe parent game object, both pipes move, scale, and rotate along with it, with the
Ah, that was way smarter.
We can then move it up above the bird, but keep the X position as 0. Finally, we can duplicate this whole top pipe object, call it bottom pipe, and flip it upside down by changing the Y scale to -1. Then move it down below the bird. As you can see, if we mess with the pipe parent game object, both pipes move, scale, and rotate along with it, with the parent as the pivot point. So let's add a script to this parent's object to make it move across the screen. We'll start by creating a variable for move speed. If we give it a number here, it will fill this as the default value in Unity, but we can always change it there. Later. Then we'll write code to move the object in update. Now, it would be lovely if we could just type transform.position.x and change this number directly, but no, boo, you have to change the entire vector in one go. Oh, and this time we're going to have to use vector 3 instead of vector 2 because the transform has 3 numbers. Even though we're making our game in 2D, Unity is still fundamentally a 3D engine, and so it's keeping track of the object's depth with the Z value. So, here's what we'll do. We'll take the current transform.position and then equals. We want to add to its current position, so write transform.position again, and then plus. And finally, in brackets, we'll do vector3.left times move speed. Back in Unity, press play, and woof, that's way too fast. Now you might think that you could just change this move speed variable to a really small number like 0.001, and that will work, but that's not actually the problem here. You see, code in update just runs as often as it can. In fact, if we check the number like 0.001, and that will work, but that's not actually the problem here. You see, code in Update just runs as often as it can. In fact, if we check the stats in Game View, we'll see the game is running at over 1,000 frames per second. Sorry, PlayStation 5, 120 FPS? Pfft, that's got nothing on Flappy Bird. And the real problem is that the game may run at different speeds on different computers, and we don't want the pipe to move faster or slower depending on your rig. Real games have actually made this mistake. In Dark Souls 2, weapon durability was once tied to frame rate, so your swords would break twice as fast at 60 FPS compared to 30 FPS. That was a whoopsie. Luckily, it's a pretty easy fix. We just multiply it by time.delta time. This ensures the multiplication happens the same no matter the frame rate. We didn't need it for the velocity.
Ah.
Velocity code because physics runs on its own little clock, but otherwise we will need it. If you want to know more about this or anything really, the Unity docs are a good place to check. You'll find info and sample code. Okay, now with that fix in place, our pipe moves smoothly across the screen. Love. Lovely. Next, we want to create a system that will continually spawn new pipes. To start, take the parent game object from the hierarchy and drag it into your project. This creates a prefabricated game object, or prefab. This is like a blueprint. Second. Sorry, PlayStation 5, 120 FPS?
It's instinct for me to click out when I'm finished editing something. Damn me. Oh, whoops. There must be something else I can change. Mass. Whatever. Turn this into 30 and then done. 28. Oops. Ugh.
FPS? Pfft, that's got nothing on Flappy Bird. And the real problem is that the game may run at different speeds on different computers, and we don't want the pipe to move faster or slower depending on your rig. Real games have actually made this mistake. In Dark Souls 2, weapon durability was once tied to frame rate, so your swords would break twice as fast at 60 FPS compared to 30 FPS. That was a whoopsie. Luckily, it's a pretty easy fix. We just multiply it by time.delta time. This ensures the multiplication happens the same no matter the frame rate. We didn't need it for the velocity code because physics runs on its own little clock, but otherwise we will need it. If you want to know more about this or anything really, the Unity docs are a good place to check. You'll find info and sample code. Okay, now with that fix in place, our pipe moves smoothly across the screen. Lovely. Next, we want to create a system that will continually spawn new pipes. To start, take the parent game object from the hierarchy and drag it into your project. This creates a prefabricated game object, or prefab. This is like a blueprint for a game object, and we can create new versions of this entire game object with all of its children, components, and properties. Oh, and before we move on, we can delete the original in our hierarchy now. Bye-bye. Let's make a new game object called Pipe Spawner. We'll put it just to the right of the camera, and we'll make a script for it. The purpose of this script is to spawn new versions of the pipe prefab every few seconds. And because the pipe already has code to move left, the pipe will automatically move across the screen as soon as it spawns in. We're going to write some code to spawn that prefab we just made, so we'll start by making a reference to the prefab. Up here, we'll type public GameObject pipe. Then in Unity, we'll use the same drag and drop method to fill the slot, but this time, instead of a component, we'll drag the prefab from the project panel. Now, Unity has a nice built-in method for spawning new game objects. We'll type instantiate and then open the bracket. In here, the command is asking for some extra details. We can actually flip through these to find different, recipes, I guess. Number 4 looks good. It will create an object at a specified position and rotation. So for the game object, we can type pipe. For position, we can just type transform.position to get the position of the object holding the script. That will make it spawn on top of the spawner. And for rotation, let's just use transform.rotation, so again, it's the same as the spawner. Let's run it, and oh my god, that's not what we want. Spawning works great, but they're coming out every single frame, and we want them to come out on a nice interval that we can control. So, back to Visual Studio. What we're going to do now is write some code to make
That good? Apparently not. I got a better idea.
a timer. This will count up for a specified number of seconds, run some code, and then start the count again. To do this, we'll need to make a couple variables. A spawn rate is how many seconds it should be between spawns. and then a timer is the number that counts up. We can make this one private as we won't be changing it in the editor or anywhere else. In update, we'll do another if statement. This time, if the timer is less than the spawn rate, then we want to make the timer count up by 1. So we'll take the timer as it currently is and add time.delta time to it. This creates a number that counts up every frame and works the same no matter what your computer's frame rate is. We can actually shorten this by changing it to plus equals, but don't feel like you need.
Alright, time.delta time. I see.
Need to make your code as short as humanly possible just to avoid getting sniffy YouTube comments. If timer equals timer plus is easier to read and grasp, then that's absolutely fine. You can always swap to the other version in the future when you feel more confident. Now, before I said an if statement is like a gate, and we can add another gate to the side of it with else. This means if the condition isn't met, then skip the code and do the code in else instead. So we'll put the spawn code in here, and also reset the timer to 0. So now, every frame, it asks if the timer is less than the spawn rate. If it is, then count the timer up. If it's not, i.e. the timer has actually met or exceeded the spawn rate, then spawn a pipe and start the timer again. Put this in Unity and pretty good. I'm happy with that. The only problem is, we have to wait ages for the first pipe to spawn. It would be good if this came out immediately, right? Now we could copy and paste the spawn code into start, so it happens once in start and then happens over and over in update. But that's a bad idea. You should generally try to avoid having the same or even similar code in multiple places. What happens if we want to change how the spawn works? We'll have to find and change it everywhere. No good. Instead, we can put the spawn code in a new function and just run that function. So here, below update, but above the final curly bracket, we'll make a function called void spawn pipe, and then cut and paste the instantiate code into there. Now we can just write spawn pipe with empty brackets in both update and start. This will run all the code in that function when these lines are executed. And with that done, it will make a pipe as soon as the game begins, and will make new pipes every time the timer maxes out. Perfect. However, this is a pretty boring game, right? The pipes always come out in the middle. We want them to come out at random heights. So remember that when we wrote the instantiate code, we had to pick a position for the object to appear? We'll change that value. Right now, the pipes always spawn on the same position as the spawner.
I wanna do that, may as well get some practice.
Now we can just write
something like that.
spawn pipe with empty brackets in both update and start.
Oops. Well, you said it was wrong when I used the lowercase. When I use an uppercase.
Start. This will run all the code in that function when these lines are executed. And with that done, it will make a pipe as soon as the game begins, and will make new pipes every time the timer maxes out. Perfect. However, this is a pretty boring game, right? The pipes always come out in the middle. We want them to come out at random heights. So remember that when we wrote the instantiate code, we had to pick a position for the object to appear? We'll change that value. Right now, the pipes always spawn on the same position as the spawner. We want the x value to be the same, but for y, we want to pick a random point somewhere above or below the spawner. So let's create a public variable for a height offset, maybe 10. And then we'll make a float called lowest point. Because we're making this variable inside the function rather than at the top of the script, it means it can only be used within the function. But it also, rather than at the lowest, a height offset, maybe 10. And then we'll make a float called lowest point. Because we're making this variable inside the function, Function rather than at the top of the script. It means it can only be used within the function, but it also means we can set it by doing a calculation. So we'll do equals transform.position.y minus height offset. And then we'll make another one for highest point, but this time it's plus height offset. That gets us these two numbers.